again. In this video, I will show you the configuration of CCL Link IE TSN network in our software GX Works 3. I'm not gonna dive deep into details about the network itself, but at this point, it's nice to know that TSN means the time-sensitive networking. So this solution, this kind of network, allows us to mix the different types of communication in one cable and provide the stable communication for different devices without any risk of interrupting each other. So in TSN network, we can combine together devices like the very fast, time-sensitive and precise devices like servo drives with the less time-sensitive like inverters or HMIs. We can even add the standard TCP/IP devices like printers or barcode readers. So we can basically build the entire automation system based on one network, on the TSN network. So I think it's enough of this introduction for now. Let's jump into software. So it's time for the network configuration. In navigation menu under our TSN master module, we look for module parameter network, where we can find all the settings that we need. In the parameter window, we start with setting the IP address of our TSN network master. In this example, I will leave it default. Then we switch to tab Basic Settings. First thing to set here is the network configuration of connected devices. So we click Detailed Settings here. Now we have to add all the devices that will be part of our TSN network. In my case, it's two remote I/O modules, one digital and one analog, the MRJ5 servo, and inverter FR E800. First, we have to define if the type of communication station is device station or motion control station. Device stations are controlled just by exchange of registers, when the motion control type are controlled by dedicated motion controllers. In our example, only the servo is motion control type, so only here we leave the marked button. Second thing that we see in this window is the number of registers exchanged by each device. It's good to keep those values somewhere because we will use them later in configuration. Then we choose parameters that we will be transferring to our devices during the system startup. In our case, we will use it for all devices where it's available. Now we have to specify those parameters and its values. So we click Detail Settings for each device. And to keep it simple, we will choose just the default initial values for all parameters. So we just click this button to copy initial values to the right values column. Then we close with reflecting the settings. And we do the same procedure for the second module. So we again just copy the default initial values of parameters. And again, we close it. Now it's time for our servo. Here the procedure is a bit different. When we click the detail setting, the MR configurator window will appear. It has to be opened because then it will build the parameter list for our device. So let's give it a second to start successfully. And once we see the list is ready, we can close MR configurator. And don't worry, as a confirmation that the parameter list was built correctly, we can see that the detail setting label changed from blue to black. Now it's time to set up the IP addresses for all our devices. When it's done, we move to column communication period setting. I will explain this in a moment. Now maybe just believe me that our servo requires the fastest basic period, and for the I/O modules we will choose a bit slower normal speed, so-called, and for the inverter we will choose the low speed. I will explain it in a moment when we will be configuring these periods by ourselves. It's also important to notice what authentication classes are assigned to our devices. So what about these classes? Maybe in simple words. The most time-sensitive, precise and fastest devices, like servo drives, will work in class B, and the rest, like inverters or HMIs, will work in class A. Yes, it's important to notice here that the B class is the superior one. So notice that our inverter works in class A and the rest of devices in class B. Now we can click our favorite close with reflecting the settings button. And we already see that we have to change the authentication class setting. Because, as you remember, we have inverter which works in class A, so we have to change this setting from authentication class B only to a mixed authentication, B and A. The next important step is to determine the registers used for communication. I mentioned to remember or keep this information about exchanged registers in each device, because now we have to determine the total number of registers of different types. We exchange registers RX and RY, exactly 96 of each, so we put these numbers here in hexadecimals. Meanwhile, we exchange 72 registers of word type, so we also have to put this information here, also in hexadecimals. Now we have to specify for all those types of communication registers to which registers of our PLC we want to assign them. Of course, we have to remember to choose right type of destination register. So for bit registers, we will use registers B, and for the word data type values, we will use the registers W. We have also to specify the range of registers that we will be using, also in hexadecimals. Now we can click Apply, it's important to click it, and then we can switch the window. So we move back to Basic Settings tab, and it's time to talk about time, and more precisely, communication period setting. As you remember, for our servo we selected Basic setting. It means that our servo will communicate with our master in period defined by these three parameters. Values required for different devices you can find in technical documentation of each device. We should take into consideration available range, type of application, and the whole network configuration. For my servo in this application, the right communication period interval setting is 500 microseconds. Time cyclic transmission I set for 200 microseconds. For remote IOs and inverter, we selected normal speed and low speed. These are expressed by those multipliers. So communication period for these modules will be basic period multiplied by following values. So inverter requires communication period interval of 5000 microseconds or longer according to documentation, and in this case we have 500 multiplied by 16, so we got 8000, which is long enough. Servo will be communicating with period interval of 500 microseconds and remote IOs with 2000 microseconds. Good news, that was the last step of our configuration. So now we can click apply and then rebuild our project. So we click rebuild all, and after this we have to rebuild also the project of our motion controller, our network master. So we open module extended parameter, and then the motion control setting function window will appear. Then we will also click rebuild all there. Rebuild all. And after rebuilding, we can close this window. Now, of course, we have to write our program and configuration to PLC. So we choose parameter and program, and we click execute. We confirm the stopping of our PLC, confirm upload, and just wait. Okay, now we can check if we did everything right. So we go to diagnostic menu and choose TSN network diagnostics. And as you can see, we have communication with all the devices that we configured. So, good job! So now you should be able to set up the CCL Link IE TSN network by yourself. You know how to add the different devices like servo drives, inverter, and remote I/O to your configuration. So you should be able to manage the whole communication for most of the machines. I think it's enough for today, and in the next episode I will focus a bit more on the diagnostic functions for TSN network that we can find in GX Works 3. So thank you for watching and see you there. Bye!